prefabricated multifunctional timber facade approach presents an alternative to demolishing and building new. This approach aims to give a new and extended life to the building, reducing time and failures on the building site, achieving industrial quality standards in building construction, reducing lifetime cost and energy consumption of the building, and using renewable energy construction materials are the characteristics of the building system for modernization. To reduce drastically the working time on building site and therefore reducing disturbance for occupants, it is crucial to move lots of passages from the building to construction site, where most of the operations are performed in a controlled environment. Therefore, a maximized level of prefabrication ensures that all the details are solved off-site, within the planning process and not later on the construction site. Of course, an integral planning team, which consists of architects, building physics and timber construction planners, and further specialized planners, is necessary in the building approach. The first part of this process is the survey and the measurement to get as much details as possible about the existing building. Within this work, the load-bearing building parts are localized and their properties are analyzed. Especially, the deeper layers of the building have to be investigated, not only surfaces. If the existing structure cannot bear the loads of the new facade, it might be subject to reinforcement. The following steps in the planning are based on the digital measurement and the creation of a 3D model. In most cases, in fact, the planning documents for the existing building are inaccurate or not available at all. Furthermore, the building construction always deviates from the planning within the range of the usual tolerances. In order to capture precisely the existing building with its geometry and openings, a digital measurement is absolutely necessary. The data for the measurement can be read directly into CAD or CAM software on site or generated in a 3D model or recorded by a surveyor. Typical measurement methods are the tachymetry, photogrammetry or 3D laser scanning. An optimal result is achieved by combining these different measurement methods. For example, a measurement with a tachymeter can be used to record the most important points of the facade. The surface structure can then be read with the 3D laser scanning, and the point cloud can be linked with the information from the tachymeter to form a very good 3D model. It is very useful to create a connection between the survey and the timber planning. This can be done by interlinking the survey with the CAD/CAM planning software. In this way, the manufacturer can draw the existing building within his planning software, thus assuring a complete model which will be used for doing the timber production planning. All the tasks of the design planning will already make use of the building model, which was delivered by the survey. Working together on one model will enable the planners to be up to date about the current planning state, identify problems or discuss about integration possibilities. The retrofit approach, using the prefabricated multifunctional timber facade, features strongly parallels to BIM design and construction process. For this reason, the prefabricated facade approach's workflow fits perfectly to the planning with the building information modeling. There is a systematic digital workflow based on a 3D model, and there are many different planners and stakeholders within the process which have to coordinate and work together. Thanks to the 3D model, the timber elements will be tailored to fit exactly like a second skin the building. The data of the timber construction planning will be used by the joinery computerized numerical control machine, and the manufacturing of the elements can begin. Once the module's dimensions are defined and the timber frame parts have been cut, they are assembled in the factory, adding main insulation and other layers, such as timber panels, membranes, cladding or the adaptation insulation layers, to complete the modules, as well as other technologies components. After the manufacturing and assembling, modules are ready for being transported to the building site. Here, modules will be installed and anchored to the existing building with the use of cranes and/or scaffolding. Final operations will be needed to connect electrical components or other integrated technologies.